Friends, so far we have studied the masonry, the different types of masonaries, different types of bonds. The masonry is made up of two different materials. One is the brick or block, and another one is mortar. Hence, it is considered as a composite material. Here we can use the different types of materials for the construction of the masonry. Maybe brick, stone, concrete blocks, it may be solid or hollow, stabilized mud blocks. We can use many type of such materials, but by using the combination of it is the combination of the mortar and the block. Hence, it is considered as a composite material. The masonry structures are intended to withstand the compressive stresses. Vertically, it is three-dimensional one. If you consider vertical direction as y-axis and the horizontal directions, both the horizontal directions as x and z axis, then that one is intended to withstand the compressive stresses. And I told that it is a composite made up of two different materials. Those two materials which will have different strength and elastic properties. The strength, it may be either compressive strength or it may be tensile strength. The elastic properties, that is the modulus of elasticity, they are having the different modulus of elasticities. And then the Poisson's ratio. Poisson's ratios are also different in the two materials. Here, because of the different properties, they are subjected to different types of stresses, maybe tensile stresses in lateral direction or compressive stresses in lateral direction. To study the properties or to examine the properties of the stresses in lateral direction of the masonry, we can examine the properties by using the masonry prism. The masonry prism is nothing but it consists of a series of masonry units kept one above the other with mortar joint which makes them which makes the which make it a single unit by combining the masonry units which make it a unique or a single unit. Here, because of the Young's modulus or Poisson's ratio, the difference in Poisson's ratio in the two materials, here the lateral stresses are also they will vary in lateral direction in both the material. Let us consider the modulus of elasticity of the mortar as Em and the modulus of elasticity of the block as Eb. Now we can examine the lateral stresses. There are two cases. In first case, Eb is greater than Em. The modulus of elasticity of the brick is greater than the modulus of elasticity of the mortar. That is the first case. In the second case, the modulus of elasticity of the brick is less than the modulus of elasticity of the mortar. That is the second case. Here, this one is the masonry prism. Here, this one is brick or block. This one is the mortar joint. Here, this is the thickness of the brick or block. This one is the thickness of the mortar joint. This one, T. That is thickness of the mortar joint. Here, while examining the compatibility and equilibrium between the two materials is achieved by the horizontal stresses such that the final lateral strain is same in both the materials, that is brick or block and the mortar. That means there is a continuity of the joint. There is a continuity of the joint. When the brick prism is subjected to the vertical compressive load or vertical compressive stresses in lateral direction, one is subjected to tension and another one is subjected to compression. Here, when EB is greater than EM, brick should be in lateral tension, tensile stress, and mortar is in lateral compressive stress. In the second case, when VB is less than EM, brick will be in lateral compressive stress, while mortar will be in lateral tensile stress. Here, we will study the first case, that is EB is greater than EM. EB is greater than EM. Here, this one is subjected to vertical compressive stress. This one is brick or block. This one is the mortar joint. Here, the thickness of this mortar joint is T. The thickness of the brick or block is D. Mu B is the Poisson's ratio of the mortar joint of the brick. Mortar joint. Mu M is the Poisson's ratio of the mortar joint. Mu B is the Poisson's ratio of the brick. Now, the vertical strain or strain along y-axis in both the materials. First one, that is brick, that one is sigma y by EB, where sigma y is the vertical compressive stress. Similarly, in mortar joint, that is sigma y by EM. Here we have to assume that the lateral stresses along both the horizontal directions, that is along x and z axis, both are equal. We have to assume like that. Then we will get the solution for that. Here, when they are free to expand, here we can assume that there is no bonding, there is no joint between, there is no bonding between the two materials, brick or block and the mortar. Then they are free to expand. If the expansion, if they are allowed to expand freely, then this one is the free expansion of the mortar and this one is the free expansion of the brick. Here, this one is the free expansion of the lateral free expansion of strain in brick due to the biaxial tension. When the masonary prism is subjected to vertical compression or compression along y-axis, both the materials are subjected to lateral stresses. Here, the lateral strain in brick due to biaxial tension. Already I told that EB is greater than EM, the brick is subjected to tension. Then in biaxial tension, the lateral strain is given by sigma B by EB in the bracket 1 minus mu B, where mu B is the Poisson's ratio of the brick. Similarly, lateral strain in mortar due to biaxial compression, that is biaxial compression, that one is sigma M in the bracket 1 minus mu M. Now, here one is subjected to tensile force, one is subjected to compressive force. The lateral tensile strain in brick, that is due to the lateral tensile strain in brick due to this tensile force. This one, that one is due to PT, that is, and then the lateral compressive strain due to PC, that one is the summation of those two equals difference in free lateral strain. Difference in free lateral strain. This one is the free expansion. This one is the free expansion. The difference between these two is the tensile strain in brick plus compressive strain in mortar. Due to the here that is lateral tensile strain in brick plus lateral compressive strain in mortar, the summation of these two, that equals difference in free lateral strains. When the restraint is applied, when the restraint is applied, already I told that if there is no joint, but we have provided the mortar joint, then they they will act as the both the materials by joining by combining both the materials, they will act as a single material, then that becomes composite material. The expansion, the free expansion or free contraction is prevented by developing a joint between those two, that is restraint is applied, then one is subjected to compression, one is subjected to tension. Here now the lateral strain in brick plus lateral compressive strain in mortar, that equals difference in free lateral strains, that is sigma b by eb in the bracket 1 minus mu b plus sigma m by em in the bracket 1 minus mu m, that equals sigma y in the bracket mu m by em plus minus mu b by eb. Then for horizontal equilibrium, here when the restraint is applied, this one is subjected to compression, this one is subjected to tension, then pc equals pt, that is pc, that is compressive strain, compressive force or compressive load in mortar, that one is sigma m into thickness of mortar joint into 1 in x and z axis, the thickness the width is assumed as unit, then this one equals, we know that stress is given by load divided by area by cross multiplication, load equals area into stress, this one is stress, this one is area, then this equals sigma b into d into 1, where sigma b is the stress in brick, d is the depth of thickness of the brick, then by sigma m equals sigma b into d by t. This is equation number 2. If you substitute this equation in above equation 1, then we will get the stress in brick after simplification, sigma b equals sigma y by sigma y into em in the bracket mu b by em, mu m by em minus mu b by eb divided by in the bracket 1 minus mu b into em by eb plus d by t into in the bracket 1 minus mu m. This one is the nature of the stress is tensile. The nature of the stress is tensile. Here by using equation 2 we can get the stress in mortar. Stress in mortar. Just now we have studied the brick is subjected to lateral tension and the mortar is subjected to a lateral compression in the two different units, two different materials or two different components. Here we will study by plotting the graph of brick lateral strain, lateral tension plotted against the ratio of EV by EM for various Poisson's ratio values. Here this one is the ratio of sigma b by b, sigma b by sigma, that is sigma b is the tensile stress in brick, this one is vertical compressive load in the composite material. Then here along x-axis EB by EM, Young's modulus of brick and the mortar. Here the first curve is for Poisson's ratio both the materials 0.1. The second curve represent the Poisson's ratio of the brick is 0.1. The Poisson's ratio of the mortar is 0.2. Here by observing this graph, here I told that brick develops horizontal tension. Here, by observing this graph, by observing this drawing, brick develops horizontal tension, which increases as the ratio of EB by EM increases. Here, gradually it increases for in the first plot, first curve, when both the Poisson's ratio are equal, as the ratio of EB by EM increases. Here this brick tension also increases. The tension in horizontal tension in the brick go on gradually, it increases like this. Similarly, horizontal tension is also sensitive to Poisson's ratio of the mortar. When if we increase the Poisson's ratio of the mortar in the second curve, here the Poisson's ratio of the mortar is 0.2. Instead of 0.1, we have increased this. Here the lateral tensile force or lateral tensile stress in brick increases. Here the sigma B increases as the ratio of the modulus of elasticity of the brick to mortar increases for the Poisson's ratio of 0.2 for mortar. That is also sensitive. As the Poisson's ratio of, by observing this, as the Poisson's ratio of the mortar increases, here in this case mu m is 0.1, that is Poisson's ratio of the mortar. In this case mu m is 0.2. As the Poisson's ratio increases, the tension in the brick also increases. In practice, this means that the failure of the masonry is caused by development of the vertical cracks like this in the direction of, in the vertical direction, the cracks will develop like this because of the lateral tension. Because of the lateral tension, the vertical cracks will develop. The failure of the masonry is caused by the development of vertical tension. If the brick is subjected to tension, the deformation may take place, the length will increase, which causes the cracks. The failure may be due to the cracks, vertical cracks in the bricks. Here this is subjected to lateral tensile force. The tensile strain capacity of the brick is the limiting factor. The tensile strain capacity of the brick is the limiting factor for the strength of brick masonry. When the modulus of elasticity of the brick is more than the modulus of elasticity of the masonry. Okay, we will continue in the next video. Thank you.